looking a little further ahead, I do think there are some really exciting interactions, for example, with the Altium platform you're talking about and others, where a designer might want to get some kind of feedback. You were talking about this, what's
Yeah.
actually, yeah, at a beginning level, just where are my boards and what's their status? But
Yeah.
then beyond that, maybe something about the defects that have occurred, right?
Yeah.
Or something that might actually affect their design decision, or certainly something that could affect the performance out in the field.
Hi, everyone. It's Judy Warner. Welcome back to the OnTrack podcast. Thanks for joining us again this week. We have a fascinating startup entrepreneur with us today that I think you're really going to enjoy. Andrew Scheuermann is the CEO and co-founder of Art Systems. He and his partner have a startup that is doing really dynamic things in the MS and contract manufacturing place and making smart manufacturing really coming to bear in a really practical way for the market. I know you're going to enjoy this conversation with Andrew, so lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Hi, Andrew. Thanks so much for taking time out of your busy schedule to join us today.
Thanks for having me, Judy. Really appreciate it.
Well, it was so fun to meet with you briefly last week and learn about what you're doing at Art Systems. And so I knew that our listeners would absolutely want to get a peek at what you're doing. Why don't you start off by telling us a little bit about how you got started, how you met your partner, Tim, and what led you to start solving some problems that are specific to the EMS and contract manufacturing space?
Yeah, be happy to. It's great to be here on the OnTrack podcast, talking about this topic. And yeah, we could, like I said, when we met last week and started talking, it was just
It's hard to
explosion of
stop.
ideas and
I know,
thoughts.
it's hard to stop.
So yeah, rolling it back. So I met my co-founder Tim Burke at Stanford University. We were both doing our PhDs in material science. We were, for those in academia, you often talk about if you're an experimentalist or a theoretical person. Tim was a theoretical person. I was an experimentalist. So he was using computer simulations, Markov chain tools, all kinds of statistical analyses to simulate physical systems, trying to predict how electrons, moved inside of electronic devices. Not exactly the same as how, machine learning AI is applied in industry, but a lot of the same tool set, same kind of thinking. And I was an experimentalist. I built semiconductor fabrication equipment, inspection machines, fabrication machines of various kinds to make the best designs and samples. And I had a world record in what's called a photoanode, a device that converted light into electrical energy to do things such as split water or do electrochemical reactions. So that was kind of what we were doing in our PhDs. And you can kind of already see, okay, maybe that has something to do with machine data and machine learning AI to predict, things that happen in a real factory, a real production line. Looking back, it seems a little obvious, but when we started a company, we definitely meandered a little bit until we found our niche. But there was another kind of key element of what we were doing that led us to want to start this company. So on the side, I helped build a startup accelerator called StartX. It spun out of Stanford University and became one of the top 5 in the world. We had a fund that invested a little more than $200 million in a whole bunch of different startups. And I got the opportunity to help lead the IoT and the hardware portfolios of this accelerator. And so I was working with both consumer and industrial type companies, but I was particularly interested in this industrial automation wave and people trying to do Internet of Things, trying to kind of collide computer science and digitization with the physical world.
Right.
And I got to both see a bunch of startups fail doing that and a few of them succeed and see a bunch of these early patterns. And then just the one other piece was back to my co-founder, Tim. He's had a lifelong passion for sustainable development. He was in the Peace Corps for a while, and he was working on this IoT device which ended up becoming the beginning of this kind of universal IoT box that we have to actually retrofit legacy machines, old machines. In an
Oh,
electronics factory, there's a lot of really
yes.
smart, amazing equipment that
Yeah.
has incredible amount of data inside,
Mm-hmm.
but certainly there are old machines as well. And he was working on this project out of Tanzania. Eventually we had a World Bank grant to retrofit around 50 different wellheads that served about 10,000 people's drinking water. And with just very simple sensors, reliably get data from these old machines to say if they were actually working and providing water. So that was kind of uh, that was the collection of influences and opportunities and challenges that we were working on that led to the early ideas of Arch.
So you can see, like you said, the collision of your two worlds and your interests and all the overlaps there. So from watching these startups, we were talking last week, you were talking about how some of the startups you observed during that time um, were not fully understanding the complexity
Mm.
of the systems for which they were trying to solve, and not understanding the full depth of that complexity sort of set them up for failure. And then you had some really key takeaways. Could you talk about that a little bit?
Yeah, absolutely. Yeah, we were talking about how software is so powerful. Software is eating the world, as Mark
It is.
Andreessen is a famous
Yeah.
investor likes to say. At the same time, there is this, I'll call it arrogance. There's this arrogance in some places of, and therefore it's easy. Software can just eat
Ugh.
everything. You just write a couple lines of code and the
Yeah.
work is done.
Mm-hmm.
And the thing is that that's worked in some spaces, the Uber and the Airbnb, the taxi company with no taxis, a hotel company with no hotels sort of thing. And it's not that it wasn't hard to build those platforms, but the amount of kind of specific understanding that they needed relative to just software understanding was low. They could just build a great software platform and it scaled incredibly. So yeah, we were talking about last week how in industrial automation, there were a lot of software entrepreneurs that kind of thought the same thing. Oh, I'm just going to build a software platform. I don't really know much about a factory. I don't know much about processes. I don't know about design, but I'm good at I can set up a cloud. I can put some APIs on this thing and
Right.
everyone will use my service. And either one, people didn't use it at all because they didn't know how or it wasn't attractive, or they used it and it really didn't provide much value at all. So it was kind of like large scale failure of a lot of these companies in the industrial space to really gain traction and move the needle. Now, there was definitely challenges on the customer sides as well. A lot of manufacturers, they weren't really ready to adopt. They had a lot of resistance. And, I think I'm sure the entrepreneurs at that time were really frustrated with the customers not being able to move
Oh.
fast enough. But it was definitely the entrepreneur, and it was the not just new startups too. I think big companies, you saw GE Digital's false starts too, that didn't understand how deep they needed to go. And so, yeah, when we started the company, we started kind of interestingly with a platform mindset. So, software and hardware technology that could be deployed across any type of machine, but we made it in such a way that we could rapidly configure it to become an expert at, this inspection machine, an expert at this fabrication machine, that sort of idea.
Mm-hmm.
But even then, we were a little too broad, more than a little bit. We were too broad in our approach of how quickly we could become experts. And so the first couple of years was a little bit of this meandering when we figured out, okay, we really need to invest. And that brought us back home to electronics manufacturing and eventually to surface mount technology as the exciting place that we were really going to invest and become world experts in. And that's, we'll talk a little more, but over the last couple of years, we've been mapping out all of the different surface mount technology machines, the exact way that their data is presented from different vendors, and how you use that to really predict and understand both simple and complex phenomena that happen on the factory floor.
Well, from my perspective in the industry, I can tell you one, I can really relate to the resistance. We have been sort of entrenched in this like 50, 60-year-old sort of mindset. And there has been iterations, but oddly, the infrastructure that makes high tech is not high tech. I mean, the machines are, but the process isn't necessarily, and it's hard. So we tend to stay head down, put our blinders on. This works, and sort of stay in that lane. And so I can understand the resistance, but I'm impressed how far you've gotten because you thought deeply about it. So I know you were doing things on the chip fab side, and industrial controls. So is that what specifically? I mean, there's a lot of industrial controls. What made you want to solve for this funny, wacky industry? Powerful
Yeah,
industry, huge industry, but still, it is complex.
yeah. I think there was a confluence of a number of factors. So we were skilled and passionate about electronics manufacturing from the beginning, which there's a lot of things that fall under that umbrella. Surface mount technology is just one. There's all kinds of final assembly and test processes inside of there. There's all the way upstream to the semiconductor fab itself and the back end. And there's all these adjacent, not directly electronics manufacturing, but metal processes, plastics, all the sort of things that go into making a final device, whether it's a medical product, a car, a smartphone.
Right.
So you really could specialize in a lot of different areas. We were drawn to surface mount technology first and foremost from our customers, trying to respond to the need. We started working with the contract manufacturers early on in EMS because that's where all the machines are. So we were kind of following the machines. Who has all the machines, who's operating them. And I think a lot of companies who have come to the space have defaulted to working with the brands and the designers, amazing companies, the Apples, Cisco's, and Johnson & Johnson's of the world, fantastic companies to work with, amazing products. And at the same time, a lot of the most interesting factories are at their suppliers or at their partners, right? Like
Right.
the
You
Flex,
bet.
Jabil, Foxcons of the world. And so we had gone to those companies, the top 10 EMS, and said, we've got this technology. Initially, it was we can get data out of any newer legacy machine, and we can standardize it and structure it for the first time to do these in-depth analytics that you've been trying to do, but you unlock it. A lot of people in machine learning AI, they say, processing and cleaning the data is 80, 90% of the battle. And that is so true in the factory, right? There is a ton of work to do to structure and clean the data. But then it's really the analytics on top, the understanding what you do with it, that provides all the value. So both of those truisms are true. It's like it's so much work to structure and clean the data, and it means nothing unless you drive value on it. And that goes back to that end to end. So surface mount technology. So who has all the machines? The contract manufacturers generally have them. And then the surface mount technology equipment is just fascinating stuff. There are these incredible pick and place machines. They place chips faster than anything you could imagine. There is a wide variety of surface mount technology machines, but it's not unmanageable. And so we've gone about kind of mapping all of the different ones and making partnerships with the great companies that make these machines, like Fuji and ASM, Koyoung, Vitrox, Panasonic. There's a manageable number of partners that we can work with and collaborate with together to be able to drive digitization. And then when we think about our company and the collaborations and the partnerships we may have, I mean, surface mount technology is ubiquitous, right? It's only one part of the process, but it's used on medical devices and automotive and consumer, and it's used pretty much everywhere.
Across every vertical, absolutely.
Exactly. So those were the things that really drew it to us, our own experience and interest, the presence of it inside of the world's largest manufacturers, its ubiquity kind of across all of the processes that we'd like to be working on in the future, and the fact that there was a manageable, high diversity challenge of new and legacy machines, yet also manageable. And it seemed like a great place for us to really become an expert, provide a lot of value to our customers, and then be able to expand our partnerships and our ecosystem from there.
One of the reasons I was so excited to talk to you is because I see so many parallels sort of in the vision that Altium is taking right now with our launch of our Nexar platform, in that it's about the ecosystem and pulling in data and intelligence in a variety of ways so we create this connected, intelligent system. We're doing it a little bit differently, but it's interesting to see it's sort of like this idea that's becoming pervasive, right? And it's bleeding in, I'm saying it, across the electronics industry. I think for our design engineers, Andrew, it would be interesting to talk just briefly about what the showstoppers are now, specifically,
Hmm.
the existing case about that all these machines, you go into a beautiful factory, you see this beautiful line, and you've got your solder paste, your 3D solder paste example. You've
Hmm.
got your SMT equipment, you have your ovens, you have, this
Hmm.
whole expansive line, right? But none of these machines, usually it's not all one manufacturer machines, and then
Exactly.
they don't speak to each other.
Hmm.
So just talk about that a little bit and what problem that creates when you're thinking about a design engineer that might just be like, why is it taking so long? Why isn't this reliable? Da, 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 and how that sort of has this, implication that they care about really, but they may not know that they care about it, but they care about it a lot.
Yeah, absolutely. So yeah, your surface mount technology line, like you said, sometimes you walk in, there might be all new machines, beautiful. Sometimes they might be old. You've you've often start out with your laser marker on the board. You've got the solder paste printer, which has some stencil specific to the product you're making. Often a solder paste inspection these days, which it can be a really valuable machine for data early on in the line. The SMT equipment, the pick and place themselves, various numbers of modules from a small manufacturer that might have only one to in tier ones, we often see lines with 14 or even more, back to back placement, especially if you're doing a highly complex board, for example, an automotive board at really high volume. AOIs sprinkled across the line, of course, the reflow oven, as you said, and that's the surface mount. There might be a pen through hole technology after that and other sort of things. That array of 5 or 6 kind of standard pieces of equipment at the front is what we target today at understanding all of those machines and their interaction between them and being able to look at both real-time data and what's happening right now on the line, an error code, a state, a problem, as well as the historical data, which is not only interesting just to train a model. Like you can look at historical data and say, okay, I've seen these 30 errors over time. Now I could predict an error or something. It's not that is valuable, but it's not only interesting for that. The historical data is very interesting to see. For example, if you had a new product going through an NPI process, what
Mm-hmm.
happened over my build? What are the different boards that happened? And even to run what sometimes we call it digital proof of concept. So if we've recorded all of the data, for example, from a new build that you've done, you might later have an idea that you didn't have in real time and say, well, I want to go back and understand, what was this correlation or what would have happened if I'd done this, right? And that's kind of where it can intersect with simulation a bit. And you can go
Wow.
back and replay the data from, last week into a new model or a new idea that you've had. And so we try to generally keep all of the historical data in a really hyper efficient format and then be able to pull it live into different things. And so, we're just starting to talk about, last week we were brainstorming, Judy, right, about the interactions that might be here because Arch's main focus today is on production efficiency. So we work with the factory, helping the factory improve its own costs, its own quality, understand the capex that it's using. If you have a line with 14 pick and place equipment, but you could actually make do with 10 and go just as fast, that's an incredible amount of money that you're just leaving there on the table. These large manufacturers have many hundreds of millions of dollars, if not more than $1 billion
You
of pick and
bet.
place assets.
Yep.
And so that's really huge for them. And that's where we focus today. And we have created a ton of value for our customers, and we're helping them become fundamentally more efficient. A lot of factories have thought, I can't do anything else to my SMT. I bought my equipment and I have 1 or 2 man operation. There's nothing else I can improve. And actually, we're finding 20 to 40, in some cases even 60%, but often 20 to
Wow.
40% efficiency improvement opportunities.
Wow.
So that's really exciting. That's been our focus today. But looking a little further ahead, I do think there are some really exciting interactions, for example, with the Altium platform you're talking about and others, where a designer might want to get some kind of feedback. You were talking about this, what's
Yeah.
actually at a beginning level, just where are my boards and what's their status. But
Yeah.
then beyond that, maybe something about the defects that have occurred, right?
Yeah.
Or something that might actually affect their design decision, or certainly something that could affect the performance out in the field. And we're seeing a lot more interest in, just to give you one example, a couple years ago, for sure, except maybe a giant manufacturer like Cisco, people maybe wouldn't even look at the quality results in the factory, just the very last tester. And if
Mm-hmm.
they did, they would only say, show me passes and fails. So I have a sense of what was the
Right.
first pass yield versus how many you repaired. And we're starting to see more interest in getting the rich data from the passes of, how close were they to a threshold, right? So say you have an
Interesting. Yeah.
ICT, an in-circuit test machine, and you could have seen that a component almost failed, but it didn't quite fail. That there was just that's too detailed. I'm not interested in that level of data, but we're starting to see more interest in that because there's a predictability of, even though I did pass, maybe I'm getting close to issues and I can yet
Well,
further kind of tune.
that makes sense to me in a really practical level because if it's close and it passes and we go, great, we did it, we succeeded, and we give that to the customer, and that ends up being in a car
Mm-hmm.
or a jet, and that can give us some predicted areas where there may be failures under stress, right? Under thermal
Yes.
stress, under environmental
Exactly.
stress, right? And so you're like, wait, I'm too close to the margin. The idea of having that kind of intelligence that affects kind of backward, into the design, I think is phenomenal. But I also know, because I came from the brutal EMS industry, working for a military EMS out of Baltimore, and one, it's super hard. It's super hard, it's super complex, and the margins are razor thin. And so these guys and gals do phenomenal work, particularly in North America, on protos pre-production, low run, or military stuff that has to stay in this country. But their margins are thin, and one bad lot or whatever wipes it out. But then the trickle down effect is the designer, the the customer, what does that do to your quality? What does this do to reliability? Hey, wonder if some of those savings that you're realizing either ends up flowing back a bit
Yeah.
to, it's we don't know fully what those implications are, but it's
Well,
unbelievable.
if I could build on what you just said, because you nailed it. It's like the quality that you can so my customers, the manufacturers themselves, the quality that they can deliver to your designers is one side of the coin, and the opposite side of the coin is the efficiency at which they can operate.
Yeah,
And
efficiency is a big deal. Yeah, talk about that.
those razor thin margins, like you said, like it's not like the manufacturers, they want to deliver best quality in the world, and they often deliver 99%
They
already.
do.
But then that idea of like, okay, I'm going to add predictive quality yet further onto that, and maybe I'll even, as is happening in medical devices, I'll just scrap everything that doesn't go through the first pass yield, like no rework sort of scenarios. Like that's a scary idea because we're on razor thin margins. Like I need that rework to be able to get as much yield as I can
And it's a
to ship.
medical device.
And so yeah, in some cases that's out of the question, right?
Pacemaker. You know what I'm saying? Like, I don't want that to fail.
But this is where that there's been kind of this I think wrong assumption. There's a paper I wrote about this called the 1%. What do you do with it? Because it was like a lot of our customers, some of the operations folks who are outstanding and they're working, they have some of the hardest jobs out there, right? They're
Seriously.
driving the economy, and they would say, Andrew, I'm a fan of technology, but I'm at 99% quality. What can you do with the 1%? And it was like, well, we can help you guarantee an even better 99% and tackle this 20 to 40% that you didn't see below the surface because you've been having to hold everything so tight, so hard to make sure you get 99%. You're actually running very efficiently to be able to do that. And previously it was like, well, that's how you do the job. There's no other way to get it done. So if you can leverage digital technology to make the operation fundamentally more efficient, then you're able to deliver, yet higher quality at lower cost. And that's the unlocking factor. One example of it is being able to do the same job, the same speed, the same or better quality with fundamentally less equipment. It's, managing your changeovers differently, the line balancing, changing the way the recipes are done on specific machines. Sometimes we'll see, for example, an inspection machine whose recipe just takes way longer than it needs to. And, maybe there's a new person at that particular factory who's not a world expert in, tweaking every part of the recipe, but maybe there's someone else in the company that can see it. Sometimes that doesn't matter. There's 5 seconds extra on your inspection recipe.
Right.
Other times, that's bottlenecking the entire line,
You
and
bet.
that 5 seconds is killing you. So being able to see exactly where that is, and it kind of intersects with remote work as another just really exciting trend, is within these manufacturers enabling the best experts wherever they are to help out, not just on their own factory, but other factories as well, and getting more leverage out of their experts. So those are some of the trends that we've been driving, which I think ultimately will lead to higher quality. But the mechanism is saving the factories fundamentally money on efficiency and then allowing them to move the bar yet further ahead.
I can see, and again, it helps having an EMS background. Somebody said to me with some technologies that we're involved in, they said, oh my gosh, if you guys do this just isn't a disruption. It's an earthquake, and that's sort of how I feel about what you're doing. So what you're saying is you're taking the data from all these dissimilar machines and you're being able to aggregate it in a way to where you could see the intelligence across the whole system. Is that a good way to frame it? If not, fix it for me, Andrew.
It is. One of the things I'll add to that is that we all the machines, all the data coming together, intelligence across the line is exactly one of the goals that we're going towards. At the same time, one of the things that we do a bit differently is when we work with a factory, we go, let's call it, orthogonally affirm that direction at first. What I mean is that we'll connect all of your pick and place equipment or all of your inspection machines across lines first. And by putting together those silos of data, we can train models faster. We can get results that maybe improve, going back to the efficiency point, improving a manufacturer's placement use across, 100 different lines and different types of products. And then over time, we connect the different asset classes. And then we start on a given individual process, connecting all of that. And so that's one way that we've, again, from the factory's point of view, we've really unlocked value and kind of how it works there. But from the designer's point of view, of course, it's like, is my line of interest have complete connectivity, right? Because I'm interested in seeing, for example, the interplay of the solder paste problems, or maybe, on the solder paste inspection, you often have a very wide tolerance window, so you don't throw out boards too far in advance.
Yeah.
But the exact parameters of how my solder paste was going down, how did they relate to, problems that I, may have had on my final product. So it's exactly the kind of long-term goal is complete intelligence across an entire line. And one of the ways that we stair-step to that is going orthogonally across machine classes and kind of creating efficiency and value for these companies that operate, many, many pieces of similar equipment.
Okay, so historically, it's interesting to note that all of these machines have their own software. And they don't want to expose that to speak to other competing potentially manufacturing code, right? So they don't want to, here, open source, I'll put all my IP in open source. No, that's not going to happen. So you guys are sort of gathering this somehow that I don't really understand. So let's talk about how so that's how you do it at a sort of local level inside a specific manufacturer, right? But are you also aggregating that data in different ways that give you other insights? Like, tell us how you aggregate that data. We're sort of talking very high level here. And I just think that's an interesting thread to pull.
Well, and maybe, Judy, I could answer. So your whole question there was kind of how are we aggregating it, across factories and driving insights?
Yes.
But maybe I could also answer, you were pointing out how exactly do you get the data out of the machine, and doesn't each machine have its
Yeah.
own software? Maybe I could
Yes.
answer both
Okay.
of
I
those
know that was a
together.
mouthful, but thank you for breaking it down.
No, I wanted to catch that point because you mentioned before too. Okay, this type of software sounds like a disruption, and I think it's a I think that's an okay word to use to say, like disrupting the way that things were done before, disrupting like how you would run a line. At the same time, something I think is really different in the industrial world is that we're the opposite of disrupting some of like the classic players in the factory. Like we're working exactly with them to build something up, and that's actually a really critical part of the strategy, which is
Mm-hmm.
um, with the machine vendors. So when we first started our company, we have the technology to go in the back of a machine and kind of plug into the raw IOs or the field bus or something like that and understand what a machine is doing.
Mm-hmm.
But that is not the way to rapidly make progress. That's not the way to partner. There are each of the companies that are building these machines, and each of those companies is a software company as well. Like they've made their hardware. Maybe it's a machine of cameras. Maybe it's the machine of pick and places. But the software is in many ways the more powerful part of that machine,
Right.
where they have already digitized a lot of its operation into some kind of API. Now the problem is it's not like the web, or it's not like
Yeah.
a bunch of modern, oh, they all talk one standard. Perfect, right? And everybody's been talking about moving towards that. And we
Yeah.
are helping drive the IPCFX as a leading standard in our space.
Mm-hmm.
But it's not there. And it might, there are some reasons it may never be there because these large and important machine manufacturing and software companies have their own standards, sometimes for good reasons, right? There are different ways to build a machine, and they, built it version A or they built it version B, and they're both valid and they're both important, and they structure their data differently.
And
And
they're all
so,
from different countries too.
oh, absolutely, that as well. Yeah. And so
So there's.
there are these lasting
Mm-hmm.
these lasting differences
Mm-hmm.
where if one of those companies said, okay, and it's just happened, I will be the standard across all machines, their competitor goes, forget it, because
Yeah.
you will definitely disrupt me. You're going to try to take me out of business.
Yes.
And so I think what we've tried to do is we've tried to come to each of those machine vendors, and we've tried to say, we're not here to go behind the door and try to retrofit your machine and redo the work you've done. We exactly want to partner with what you're doing. We want to help you actually sell your APIs and your software to the factory, have it used better, and then add, as you were asking, that aggregation layer on top. And that does cost the manufacturer real money. And so we kind of take on, we think we can create that much efficiency, that much value. And we've been able to do that. And so a lot of the machine companies are actually our partners, some of our closest partners. We've been able to drive sales for them. And so then when you ask the question of how do you get data out of the machine, ideally, we work with the factories to upgrade them to the latest software, the latest standard. And then we have a library of drivers or connectors that can talk to that given vendor's software in a modern way, in a different way for machine A versus B versus C, but each in a modern, software to software way. And then we do the universal translation into either, it could be an IPCFX standard or just some kind of standard format that allows us to do that work. And that's where the aggregation happens
Okay.
across lines and across factories to be able to mine, finally that bigger data set all put together.
And so you've baked in a way to protect their their IP from other competitors, but you've also enabled them to sell more, right? So everybody wins. The manufacturer wins, the equipment manufacturer wins. Do you want to touch on? I don't know if it's too big of a pool to dive into practically, but you do have data security measures in place that
Absolutely.
protect that custom software, right?
Yeah. Security is a hugely important topic with all the ransomware, the SolarWinds, all the things that have happened. Everybody has to take that extraordinarily seriously. And that's actually yet another reason for a data company like us to work with these machine vendors, because you cannot, in many cases, open these machines directly to the internet. They're not, and they can't be inherently secured because the machines need to expose these rich bidirectional interfaces to be able to control them. But you start putting control interfaces directly on the internet, you're asking for trouble, right?
You bet.
And so what we do fundamentally for security, it's a big important topic, but just keeping it really short and to the point, is we have a hybrid product, right? We are on premise and in the cloud, and we believe it's always both. It's not one or the other. So we deploy part of our product called the ArchFX Broker. It's a messaging broker system. Part of that universal translation layer gets deployed on premise. It makes a secure connection to the machines inside of the customer's network, inside the firewall, completely connected. It is actually possible for us to sell that product completely by itself, and there's like zero cloud component. But the magic happens when you open that to the cloud. And so we work with our customers' IT departments, and we can open secure, encrypted, read-only ports that have blocked all downstream access. So our brokers access in security what's called a bastion server. So it closes the door. It does all the communication and edge computing things it needs to with the machines,
Mm-hmm.
but it gets the necessary data, and then you have an encrypted one-way route out that fills this massive data lake. And then in the data lake, you can inspect the data that's going out. If you want to talk about defense, for example, that's where things like the GovCloud and also just the ability to control, which data do I send and not send
Right.
is in the control of the customer. But for the most part, this data is not sensitive. It's, error codes, it's speeds,
I
it's,
see.
mispicks, it's specific defect codes. And so this data is, in fact, very good to work with in the cloud, and then fill it up and take advantage of this large scale data lake, which gives you, access to all these powerful technologies in the cloud. So that at a high level, that's how it works. The one other piece that we do is that we just have classic good cloud security. With some of our customers, we have, of course, division by roles, by organization. With our large customers, we actually stand up virtual private clouds for every single customer. So we operate kind of a network of clouds for our customers. So they both have part of the system inside of their premise, and then they have a completely isolated cloud section as well, that allows them to really be in the driver's seat. So that increased the complexity of what we had to do to have an enterprise grade product, but it's been enabling these large manufacturers to go to the cloud and have the security that they need.
Well, I think this is, and you're using AI. I think it's interesting message. You've talked about your partner, Tim, being sort of the mastermind behind all of this. But again, it's something that kind of like a duck on a pond. It looks like it's easy while they're gliding across the pond, but their feet are going a million miles an hour under the water. Sounds like
That
anything further that's interesting around sort of that AI. I think the predictive part is massive.
Yeah, I think that analogy of a duck you just made is essential because there is a lot of hard work to be done here. And it kind of ties it all together. The need to become an expert in a specific vertical, the need to then wrap all this complex technology into ultimately the simple dashboard, the simple recommendation at the
Yeah.
end of it. That's really what we consider the AI part too, because in fact, we even use the words this way in our company. If you take all this massive data, you do this huge statistics, we call it advanced statistics or advanced analytics. And some people call that AI as well. You're doing some of the advanced stuff, but you're
Mm-hmm.
leaving it complex to the customer, often in a way that they can't use it. So it's not actually a very intelligent system, so to speak. Like an
I see.
intelligent system, like a person understands, I got all this computation going on, and now I can synthesize it, and here's the answer. Here's
Right.
actually what you need to do, and it's correct, right? And it's not just like totally off. And
Right.
so we use the word AI to communicate when we've achieved that complexity and the bringing it then down to the simple insight, the simple conclusion that the factory needs. And
Mm-hmm.
that's not easy to do.
No.
And it takes both a mastery of the technology and a mastery of the process, which is why we've specialized in surface mount technology. And by no means have we mapped every single machine, every signal to an insight, but we are in the process of doing that and working with some of the best customers in the world. We have a presence in 5 of the 10 largest EMS by size, and in many of these we have kind of councils of top process SMEs working with us to
Mm-hmm.
help us continually with this mapping and this simplification.
So that's kind of where I wanted to go as we start to wrap up here, Andrew, is the adoption. So, I mean, you're a tech startup in Silicon Valley, and you haven't been around that long, but that you're making inroads into 5 of the top 10 is massive. So, which tells me you're swinging the bat in the right direction. What's the feedback on that so far that you're getting, and what's ahead?
Hmm. Yeah, we're headquartered in Silicon Valley. I'm sitting in Palo Alto right now. We also built a distributed team kind of before COVID that was more popular because we were like, yeah, we're small, but our customers are all over the place.
Yeah.
Um, Flex, just to name one of our customers, is in 30 plus countries. And so we have a small team, but we exist in 5 countries. Our team is distributed as well all over the place to serve
Mm-hmm.
them. Yeah, the traction has been, that's
Yeah.
the startup, the business word for progress, but the engagement with our customers has been outstanding. We had early customers that saw the technology, saw the promise that we had, and made this tight partnership with us to bring the process SMEs. And then
Mm-hmm.
we brought the commitment to become
Mm-hmm.
experts,
Mm-hmm.
and that has illuminated the path. So the feedback that we always have from our top customers is, wow, like you're actually doing it. Like you actually understand the process, and you're actually doing the real work. This is great.
Mm-hmm.
We want to work with you. And a lot of folks are also surprised initially at the specific KPIs and the analytics we do that show these inefficiencies, which they kind of knew were there, but they just hadn't been brought to light as much.
Right.
And they're like, wow, there's actually a lot to improve here. And that gets people excited to engage and to move ahead. And I think the other thing people are really excited about is the cost. So it does not cost as much as people think by far. And we even have at our lowest tier, we have an engagement model that's $2,000 per factory per month. And that actually includes a lot of data and analytics and intelligence built into it. And people think about, $2,000 and they're like, nothing costs
Nothing.
$2,000, right?
Yeah.
And so now everything can't be done for that level,
Of
but
course.
we have been able to do a certain packaging of these insights that can be very effectively scaled out across factories rapidly. So the combination of those, I think, has allowed us to have a really good engagement model and start working with folks. And for us, it's about the ecosystem, because if we were just working with 2 factories and one partner, we would never get anywhere. And so we need to be
Right.
working with the majority of the factories out there, the majorities of partners, and putting this thing together. And we need to be building this kind of open engine with open APIs, the protection of everybody's IP, in order to try to play this role as a data facilitator.
Well, this has been the funnest conversation I've had in a while. I'm really, really genuinely excited about what you're doing. And I've seen, as we wrap up here, I've seen factories specifically in Silicon Valley build their own custom software to get some of what you're talking about, and spend $2 million and hire software coders to make that happen just for one local factory, smallish based on from a
Hmm.
global standpoint. And they did it with a smile on their face, but it yielded such great results. It was worth it. The ROI was worth it. So what you're offering is just monumental. And again, I think about the bulk of our audience here is design engineers. Well, why should they care? Well, they should care because it's going to have a direct effect on their product. And this idea of ecosystem is one we're embracing here too. And the more that ecosystem collaborates together and doesn't stay in these silos like we have historically, as long as everybody's, IP is protected, man, I think we're going to see major transformation in the industry. And congratulations to you and Tim and your whole team for just outstanding model and success. And you need to come back and keep us up to date, Andrew. I've really, really enjoyed our conversation.
Oh, for sure. We're a happy customer of Altium. Love the products and loved being on the OnTrack podcast here, Judy. So yeah, please, love to be back. Love to chat more. Looking forward to talking about more ways to collaborating with you and your listeners. So
Thank you so much, Andrew. For our listeners, I have loaded up the show notes for you. We've put in the Art Systems website where you can learn more. There's an overview video that'll probably say what Andrew and I talked about today in a more brief, marketing savvy kind of way. And also, there is an article that really goes, is much more articulate than I am for sure. And so I'm going to share all that below. And make sure you check that out and make sure you subscribe, like, and come back and see us and tell us what you thought of today's podcast and this conversation with Andrew. We will see you next time. Until then, remember to stay healthy, stay safe, and always remember to stay on track.